Hello students, this is Dilip Udhani, Assistant Professor at LJ Institute of Engineering and Technology. Today I will teach you HOD, that is higher order differential equations. So in this lecture I will teach you shortcut methods to find particular integral. We will discuss the solution of the differential equation of the form function of dy equals to x, that is called higher order non-homogeneous linear differential equation, that is function of dy equals to x, and its solution is given by y equals to cf plus pi, where cf is called complementary function and pi is called particular integral. So particular integral is given by the formula 1 by function of dx. Okay, so how to find pi and cf of the equation function of dy equals to x? I will explain you this with the help of example. And we have different cases to find out pi for the equation f of dy equals to x. So we will see case first today, that is when x equals to e raised to ax plus b. So in this case, to find out pi, we will write down the formula of pi, that is equals to 1 over function of d into x, and that is equals to 1 over function of d, replace x by e raised to ax plus b. Now what we have to do, we have to replace this d by a. So it will become 1 over f of a into e raised to ax plus b. But we can write it in this form only when f of a is not equals to 0. Now if f of a equals to 0, then in that case pi will be, you have to differentiate function of d with respect to d, so it will become f dash d. Then after you have to multiply it by x, and you have to write down e raised to ax plus b as it is, and then after you have to replace d by a. So in the denominator it will become f dash a, this one x will be as it is, and e raised to ax plus b will be as it is. Now you can write in this form only when f dash a is not equals to 0. If f dash a will become 0, then again you have to find out the derivative of f dash d. So it will become f double dash d, and you have to multiply numerator by x square, and then after you have to replace d by a. So in the denominator you will be having f double dash a, and f double dash a should not equals to 0. In this way you have to repeat the process. Okay, now we will see example related to this topic. Example number 1. Solve the differential equation, that is d square y by dx square minus 5 dy by dx plus 6y equals to e raised to 4x. Now we know that d by dx is a differential operator. So we will replace d by dx by d, and d square by dx square by d square. So it will become d square y minus 5 dy plus 6y, that is equals to e raised to 4x. Now taking y common, so we have d square minus 5d plus 6y equals to e raised to 4x. Now this differential equation is of the form function of dy equals to x. So its solution will be given by y equals to cf plus pi. So first of all, we will find out cf, that is complementary function. To find out complementary function, we have to write down the auxiliary equation. And auxiliary equation is given by this function of d, equating this function of d to 0. So we will be having an auxiliary equation. Then after, we have to factorize this equation to find out the values of d. So this equation is d square minus 5d plus 6 equals to 0. Now we have to split the middle term. We have to split 5d, right? We have to find out two numbers such that their product is 6 and their addition is 5. That is 3 2 is 6. So first term d square will be as it is. Last term plus 6 will be as it is. And splitting the term minus 5d into two terms, minus 3d and minus 2d, that is equals to 0. Now taking d common from these two terms, so we have in bracket d minus 3. Now taking common minus 2 from these two terms, we have into bracket d minus 3, that is equals to 0. Now again taking common d minus 3, so in one bracket we will be having d minus 3, and in other bracket we will be having d minus 2 equals to 0. Now equating these two factors to 0, we have d equals to 2 and d equals to 3. Here we are getting two distinct values of d, and both of these two values are real values. So we will write down cf in this manner, that is e raised to 2x, then after e raised to 3x, and then after write down its linear combination. For linear combination, you have to multiply e raised to 2x and e raised to 3x by the constant values, and then after you have to add the result. So CF will be C1 e raised to 2x plus C2 e raised to 3x. If the values of D, say that will be 1, 2, 3. So in that case, what will be CF? So in that case, CF will be C1 e raised to 1x plus C2 e raised to 2x plus C3 e raised to 3x, in this way. Okay. Now we will find out Pi. The formula of Pi is 1 over function of d into x. So 1 over function of d. This is function of d, that is d square minus 5d plus 6, d square minus 5d plus 6, and x is e raised to 4x. Now applying shortcut method, so we have to replace d by 4. So it will become 4 square, that is 16. Then after minus 5, value of d is 4, so 5 4s are 20. Then after plus 6, and e raised to 4x will be as it is. Now 16 plus 6, that is 22, and 22 minus 20, that is 2. So e raised to 4x divided by 2, this is the required pi. So the general solution is y equals to cf plus pi, and cf is c1 e raised to 2x plus c2 e raised to 3x. Okay, then after pi is plus e raised to 4x by 2. So this is the general solution of the differential equation, this one. Okay, now we will see example number 2 related to this topic, that is d square minus 2d plus 1y equals to 10 into e raised to 1x. Now again you can see that this differential equation is of the form function of dy equals to x, where function of d is d square minus 2d plus 1 and x is 10 e raised to 1x. So its solution will be y equals to cf plus pi, where cf is complementary function and pi is particular integral. To find cf, we have to find out an auxiliary equation. and that is given by equating function of d to 0. Here function of d is d square minus 2d plus 1, right? So we have equated this equation to 0. Now applying the formula of a square minus 2ab plus b square on this trinomial, okay? So we will be having d minus 1 the whole square. If you have been given a square minus 2ab plus b square, so it will become a minus b the whole square, right? So in this case, the value of a is d and the value of b is 1. So it will become d minus 1 the whole square equals to 0. So we have two factors, d minus 1, d minus 1. So we have two values of d. One is 1 and other is 1. So here we are getting repeated values of d. So for this one, we will write down CF as e raised to 1x. Then after, here 1 is repeated, right? So what you have to do, you have to write down e raised to 1x, and then after you have to multiply it by x, and then after you have to write down its linear combination. So that will be c1 e raised to 1x plus c2x into e raised to x, and taking e raised to x common, so we have cf equals to c1 plus c2x into e raised to 1x. Okay, now pi is given by the formula 1 by function of d rx. Function of d is d square minus 2d plus 1, and rx or x, that is 10 into e raised to 1x. Okay, now if you will replace d by 1, see this is the value of a and that is 1. So it will become 1 square minus 2 into 1 plus 1. So 1 plus 1 is 2 and 2 minus 2 is 0, right? So we will not replace d by 1. What we will do, we will differentiate this function and multiply the numerator by x. So in the numerator we have x into 10 e raised to 1x, and derivative of d square is 2d. Then after minus 2 sim, and derivative of d is 1, and 1 is a constant value, so its derivative will be 0. Then after we will replace d by 1 because the value of a is 1, and if you will replace d by 1 over here, so it will become 2 minus 2, and 2 minus 2 again it will become 0. So what we have to do, we have to again multiply numerator by x, so it will become x square, and this 10 e raised to 1x will be as it is, and we will differentiate 2d minus 2 with respect to d. So 2 will be as it is, and derivative of d is 1. Then after minus 2, and its derivative will be 0. So in the denominator we will be having 2 only, and there is no function of d in the denominator. So this is the final answer, but you have to simplify this. So 10 divided by 2, the result is 5. So overall it will be 5x square e raised to 1x. So this is the required pi. Okay, so the general solution will be y equals to cf plus vi. Cf is c1 plus c2x into bracket e raised to 1x, that is this one, plus pi is 5x square into e raised to 1x. So this is the required general solution of the differential equation d square minus 2d plus 1y equals to 10 e raised to 1x. Okay, in the next lecture we will see second case, right? Thank you for watching this video.